All right, let's hear from the crowd. Pod 1, what's something that you talked about?
For problems like number 7, which is 4 to the x equals 16, you can just divide the one that doesn't have the exponent on it and see how many times it takes to get to 1.
Okay, kind of like a... I don't know what you mean.
So like you take 16 and you divide it by 4, and you just keep dividing whatever number it is by 4 until you get to 1.
Okay. Okay. I see what you're saying. Okay. Pod 2. I think. Okay, so converting forms, if it's a logarithmic, we can write it as an exponential function. If it's an exponential, we can write it as a logarithmic. That's very good. Okay, pod 3.
Solve for x.
Okay. Pod 4.
We said for like problems like 45 to 62, we said isolate and then rewrite it.
Isolate, then rewrite. Okay, good. Pod 5, anything to add?
Solve for x.
Okay, all right. We're still waking up this morning, right? How many of you got woken up by the storm last night? That's it? Oh, it was loud.
I was actually happy.
Good job for you if you slept through it then. We're going to have to go ahead and do this real quick. Okay, so today, as you can see, we are going to... Okay, we are going to solve equations that involve either logarithms or exponents. All right? So if I can get my smartboard to recognize that I'm touching it here. Okay, so strategies for solving logarithmic and exponential equations. Okay, I think, Pod 2 said something about rewriting. Pod 4, you said isolate and then rewrite. Okay, I think that, you said it very well. Make sure you have a logarithm or exponential piece by itself before rewriting, okay? So for an exponential, we may want to isolate and then rewrite. Come on. Rewrite. As a logarithm. For a logarithmic, we can isolate and then rewrite as an exponential. Okay. There are a couple other things we need to consider when solving these equations. Okay. You have a good start. You recognize, all right, we can change forms. However, that's not always our only option. There will be times that you will need to use your condensing or expanding properties before you can rewrite. Okay, most of the time it's going to be the condensing, okay? Condense it down to one logarithm so you can rewrite, okay? There's also a property that we used for both logarithms and exponentials. Do you remember the one-to-one property that we talked about last week? The one-to-one property for both exponentials and logarithmic equations could be helpful, okay? If you have two logarithms that are equal, all right, the one-to-one property may be what you need to do to solve your equation, okay? Basically, we need to to be able to problem solve through these equations, okay, in order to be able to solve, all right? It's not always going to be as cut and dry as rewrite it. That's all you got to do, okay? Not all the time, all right? We will need our knowledge of properties, both for like the condensing, expanding, and the one-to-one property to help us, okay? So this is what we're going to do. Okay, first of all, you have solved some of these equations before. So we're going to start slow, and we're going to look at some that you've seen before. We are going to look at some equations that you have not seen before. And then I'm going to give you an activity to get some more practice. All right? So let's first start with some exponential equations. Go ahead and write this first one down. We have 2 times the quantity 5 to the 2x plus 3 power equals 32. You will need your calculator for these, so if you want to go ahead and get that out now, that would be a good idea. All right, so what do we need to do first in order to be able to solve for x? Okay, we have to isolate the exponential piece, which means we need to first divide by 2. Okay, now we have a base raised to an exponent equals a number. Okay, this is the perfect time to go ahead and rewrite. All right, so we can rewrite as log base what? Log base 5 of 16 equals the 2x plus 3. From here it becomes a linear equation, okay? What are we going to do to solve for x, okay? We're going to have to take log base 5 of 16. We're going to have to subtract that 3 over and then divide by 2 to solve for x, okay? So go ahead in your calculator, figure out what log base 5 of 16 is, subtract from 3 divided 2 to get what this should be. Wayne, did you get something?
I got -0.16.
Do you agree with Liam's answer? Good. Is everyone okay with the change of base theorem? Getting the log base 5 of 16? All right, our next problem. E to the 2x minus 4e to the x minus 5 equals 0. Oop. There we go. Thoughts? What does this mean?
Okay.
How do we condense it?
I was thinking maybe like move the 5 over to their side and then convert the e's to like the natural log and then combine them. I don't know if that's deep.
So the problem with that is it has to be one single equation to be able to convert to the natural logs. Do you see what I'm saying? And we have 2 different things going on the left side there. Okay? So it's not, I mean, you have a good idea, I just don't know how to execute it since we have two of them. Okay, Nick.
Factor.
If I gave you that, what would you do? Factor to what? Okay. So e to the 2x minus 4 e to the x minus 5, it's a trinomial in disguise. Instead of x, we have e to the x. Okay? So we can factor this to e to the x minus 5 times e to the x plus 1 equals 0. Why is that a trinomial? I don't see an x squared. Well, e to the x times e to the x would be what? E to the 2x, because we add our exponents, okay? So it is a trinomial in disguise. Okay? Now we can come back to what you were saying, Caleb. Okay? Now we have e to the x minus 5 equals 0, and e to the x plus 1 equals 0. So if e to the x equals 5, then log base e of 5 equals x. And if e to the x plus 1 equals 0, then, e to the x equals negative 1, and log base e of negative 1 equals x. Why not? We can't have negatives inside of our logarithm, so that answer is not going to work. And you could come across problems like this. Algebraically, we get something that works. But since our logarithmic functions are restricted, it may not always work with the logarithmic part of it. Yes?
Is that how they find pi? Because when I plugged it in, it gave me like pi to that. Pi gave me 3.141596654.
Very interesting. So we only get one answer, even though we had kind of a quadratic type of problem, because our second answer doesn't make sense in our problem. Okay? We might get something that algebraically can work, but not inside the function itself. Okay. All right, my favorite problem today. Okay. Please be very careful as we go through this problem. It is a problem you have never seen before, but you will see again more than one time. Okay? So I need you to take careful notes and follow along and ask questions. Okay? What's the issue here? We don't have the same base. Can we make the same base? Okay? 3 is a prime number, right? 4 is not a prime number, but it doesn't have any factors of 3. Okay, if that were like an 8 to the x and 4 to the x minus 1, we'd be okay. We could use the 1-to-1 property because we could make them each base 2. But 3 and 4, they don't have anything in common, all right? We cannot write them as the same base. So we are going to have to use what we know about logarithms to help us. Okay? We can't rewrite it. However, we have some properties with logarithms that enable us to condense or expand or combine logarithms together. So logarithms can sometimes be easier to work with than exponents. So this is what we can do. As long as we do something to one side and to the other side, we don't change the value of our equation. Do you agree? Okay. So what we can do is we can force this to be a logarithmic equation by taking the natural log to both sides. And it wouldn't really matter which logarithm we take, but natural log is nice. Okay? So we can take the natural log to both sides. We haven't changed the value of the equation. It just looks different. Okay? Well, now what can we do with this? We have these exponents here, right? What can we do with exponents that are inside logarithms? We can multiply them out in front. So that x can multiply out in front of the natural log of 3. And this x minus 1 can multiply out in front of the natural log of 4. Okay. And since we have x minus 1, the quantity, times the natural log of 4, we can actually distribute that through. So what we have is x times the natural log of 4 minus the natural log of 4. Okay. Our ultimate goal is to do what? Our end goal is to do what? We need to isolate x. Okay, we have two terms up there with an x, okay? That's not new to us. This occurred to us when we found inverses in chapter 1, okay? We have two different terms that have an x. We need to get them together somehow, all right? So what I'm going to do is I'm going to leave x natural log of 4 right here. I'm going to subtract x natural log of 3 to be with it. And then since this negative natural log of 4 doesn't have an x, I'm going to add it over to the other side. Okay? So everything that had an x, I put on the right side. Anything that didn't have an x, I put on the left side. Okay? Now what can we do with this right side? Well, technically, yes. But if our ultimate goal is to solve for x, condensing might take us a couple steps backwards because it would put it back inside of the logarithm. Okay? If our ultimate goal is to solve for x, what do those two terms have? An x, which means we can do what with it? Maverick, what do you think? Almost. We will divide soon. Before we can divide, we need to factor out that x. So then we have this number right here to divide by. Okay. So now to get x by itself, in your calculator, you need to take the natural log of 4, and you need to divide it by the quantity natural log of 4 minus natural log of 3. Get 4.819. What?
What do you divide it by after taking natural log of 4?
Then you want to divide it by just number, like to get x by itself, you want to divide it. So you're taking the natural log of 4. Okay. Fun and different and exciting, right? Okay. Questions on this problem before we move on? You will have a problem like this in your homework, for sure. Maybe even in the activity we did this right after we're done. Going once, going twice. Did you get a key? Awesome. All right, let's switch modes to a couple logarithmic equations. First thing I'd ask myself, is the logarithm isolated? It is. It is. Now, there are a couple different ways that you could go about this problem, but it is perfectly fine to keep it like this and rewrite it. So this is log base e. So we can write e to the power of 5 equals the square root of x minus 8. Some of you may choose to expand that logarithm and take care of the power first. Either way, we're still going to get to the same place. Okay? So now, since x minus 8 is underneath the square root, how are we going to get it out? So if I take the square root and take it to the 1/2 square root. Okay, okay. So we need to square both sides so that the square root and square cancel. And we have e to the power of 10 equals x minus 8. So now x is going to be e to the 10th power plus 8. You'll have to approximate that with your calculator. It's probably going to be a big number if you are taking e to the 10th power, right? Chris, what'd you get?
2034.466.
All right, last example. Are you ready? And we'll turn the lights on and we'll get you doing some work. Log base 2 of x minus log base 2 of x plus 1 equals 2. All right. What is our first step? Can we rewrite into an exponential right now? No, that is not always going to be the answer. What can be done on the left side? Eli, what can we do?
Condense.
We can condense it. So you're saying that log base 2 of x divided by x plus 1 equals 2. That's what we need to do? Okay, so we can condense it using those properties. Now, what are we going to do? Now we can rewrite it as an exponential equation. So we have 2 to the second equals x over x plus 1. All right, now we need to solve for x. Okay? We don't always like having that fraction on the right side, so let's make it to where we don't have a fraction. All right? We can take, okay, so this is 4. We can multiply that x plus 1 over. So we have 4x plus 4 equals x. Which means 4 equals negative 3x. equals negative 4/3. That's our answer? Caleb, what do you notice?
You plug that in, it doesn't work.
If we plug negative 4/3 in to our equation, it does not work in the domain of either one of our logarithms, okay?
What if it's just one?
What if it's just one? It's still not okay. If it makes one logarithm negative inside, it doesn't work. Algebraically, we get it to work here with this linear equation. We get an answer with the linear equation, but we can't actually plug it into our logarithm, so we don't have a solution. There is no solution to this problem. Okay. If this were a problem on the test, I would want to see all of the work, and then I would want to see that answer of negative 4/3 canceled out. That you got the negative 4/3 and then realize that that's not going to work and then give me no solution. If there is no work and it says no solution, no, that's not going to get it. Okay. Yes?
If we get halfway through the problem and realize it's going to be no solution, do we have to continue and get the answer? And then cross it out?
Well, if you realize it's not going to be a solution, at least get to the answer that you know it's going to be negative, right?
Yeah.
Now, just because the x is negative doesn't mean it's going to be no solution. If this were like x plus 2 and x plus 5, negative 4/3 would be just fine. But it's the fact that we plug it in and it's not going to be okay that makes it no solution. Okay? But I do want to see, like, what the answer would be so that, do you see what I'm saying? I want to see it through your eyes. All right, so I am going to give you and a partner a set of dominoes, okay? And how these dominoes work is there's going to be an answer on the left side and a question on the right side. So I want you to just pick a question, do the problem, and then you need to find the domino that has that answer and match it up. And then that'll give you the next problem to do. Find the answer, match it up. That'll give you the next problem. Does that make sense? Okay. When you're done, when you have all of these dominoes lined up, the last domino should be the answer that's on your first domino. You still have to do that problem. Okay. But you need to make sure that they circle back around. Okay. So I'm going to group you up the best that I can without wasting too much time. So I think I'm going to keep you in your seats. Okay. Your homework is on the gold sheet, so when you do get done,